Hi, welcome back to Property and Structures of Matter, and today we're looking at rules for filling the orbitals. So in our last video we looked at the Schrödinger model and the SPD and F orbitals, and we showed you the pattern of filling those up. But there are, as always, some rules for our chemical or chemistry procedures that we need to remember. So let's have a look at some of those rules. The first one we have is the Pauli exclusion principle. Now, while we've talked about orbitals and we've talked about orbitals can only fit 2 electrons, each of them have to have what we call spin, a quantum mechanical property called spin. So what that means is if one is assigned a spin of +1/2, so it's positive, it's in one direction, then the other must have a down spin. So it's an opposing spin. Similar a little bit to magnets where, one direction and another direction. We have to fill our electrons according to spin. So if you look at the diagram on the right hand side, you can see that we're filling our electrons. So in that first 1s orbital, one electron has a positive spin, the other electron has a negative spin, and then we fill our next s orbital. And when we fill the next one, it doesn't matter which direction, if it goes spin up or spin down, because there's only one electron in there. I tend to just fill up, but there's no rules against that. So you can see that in the second one for the same one there, it's filling it down this time. But in the third example here, you can see that I have put one up in one electron, in one orbital, and one down in the next. What we have to have is the spin of the second electron will depend on the spin of the first. So even though they aren't in the same orbital, we need to be putting them in order in the same sort of direction. So in the next one here, as long as you draw the first electron in each orbital as spin up, you draw them all spin up first. We'll look at some examples that will help you a bit more. So another rule that we have is the Aufbau principle, and this principle states that we must fill the lowest energy levels first with electrons before we can move on to filling any higher electrons shells, which we've been doing anyway, so this should come as no real surprise. So we have to fill the s orbital first, the first shell, so 2 electrons can go in there. In the second s orbital, 2 electrons can go in there as well. We put 6, there's 3 sets of 2 in the third, then we fill up the s. We fill up the s before we can fill up the next p, and so forth. Like I said, it's what we've been doing anyway. And the last one is Hund's rule. Now, Hund's rule states that every orbital in a subshell must be first filled with an electron of the same spin before we can fill the second electron. So in this example here, the first shell's pretty easy, so 1 up, 1 down, it's done. The next one, 1 up, 1 down, or positive spin, negative spin, it's done. When I go to filling my p orbital, I have to put all those ones in of the same spin first. So I have to fill each orbital. I don't fill the first box first, then the second, then the third. I have to put one of positive spin in each of those 3 orbitals and then come back and put the negative spin in. So let's have a go. So say, for example, F, fluorine, is element number 9. What are we going to do here? So we're going to have to fill our orbital first. So spin up, spin down, spin up, spin down. So now we're at 4 electrons have gone in. So we have 9 electrons. We've got 5 more to go. So we have to put our positive spin in first. Then we come back and fill our other spin in there, our negative spin in there. So there is 1 orbital there with only 1 electron with a positive spin in it. Have a go at magnesium here yourself, and we will practice many more of these in class. It may seem repetitive, but we're going to practice loads of these because it is practice that does make perfect. See you then.